Now we'll be solving question number 60 from exercise 2 of laws of motion chapter, phase 1. A block of mass 3 kg is at rest on a rough inclined plane. So this block is there on a rough inclined plane. It is at rest. It is at rest. As shown in the figure, the magnitude of net force exerted by the surface on the block will be. The beauty of this question is in the language. They're talking about magnitude of net force exerted by the surface. Before calculating the net force exerted by the surface, we should know what are the forces which are applied by the surface. So what are the forces this surface is applying onto this? So as we discussed, there are two forces. The force which is applied is actually the contact force. And that contact force we study as two components, normal reaction and friction. So when they're talking about net force exerted, they're talking about the net of normal and friction in this particular case. Meaning to solve this equation, I need to calculate both friction as well as normal, and then we will be taking the net of those. So let's make the F vary. With it tilted word. So mg is acting downward on this system. This angle is theta. This is theta. So here we are getting mg sine theta from this angle, and here we are getting mg cos theta from this angle. But towards the angle side, cos, other side sine. Now this mg cos theta will be balanced by normal reaction because this cannot move in this direction. And this mg sin theta will be balanced by the friction because the thing is, block is not moving. So this friction will not be kinetic in nature. This friction is static friction. So along this line, when we balance, I get normal as mg cos theta. And along this line, I get friction as mg sin theta. They're talking about net. So both normal and the friction, they are mutually perpendicular. And we know how to calculate the net of two forces which are mutually perpendicular. So net force, contact force will be equals to under root of n square plus friction square. And actually there was plus of 2f cos theta, and theta is 90, so that term becomes 0. In the vector we have learned that. That is equals to m square g square cos square theta plus m square g square sin square theta, and we'll get it as mg. Sin square theta plus cos square theta will be 1. Mass is 3 kg. You multiply with g, you get 30 Newton as a force. The option is D in this case. So it's an easy question. I hope you understand that. Thank you.